Hello, my name is Axel Schick and I test fluids in electric drive units. Today I want to show you a special e-fluid test stand. So let's go inside. As you may know, today e-drive units have gear units to reduce the speed of the electric motor to the speeds needed at the wheels of the vehicle. These fluids provide lubrication and cooling at a very high efficiency. Depending on the chemical composition, these fluids could also be used to cool the electric motor. Especially the end windings of the stators can be cooled directly, as these fluids are usually electrically isolating. Our unit under test is an automotive electric motor from Borg-Warner with a special oil spray cooling of the starter end winding. The rotor is also cooled by the oil through a hollow shaft. The temperatures at the copper end windings or their isolations is limiting the current that can be sent through the motor and thus the maximum power of the drive unit. If I'm able to send more current through the motor by a more efficient cooling, I can get more power out of it. Well, the cooling is also a function of the fluid properties. Some of our customers are producers of such fluids and have now a tool to optimize the cooling properties of their e-fluids.
Hi, I'm Ruven Kirchhoff and I work for APL as a project engineer. My focus is on testing all kinds of fluids in electric drive units. In this video, I would like to show you a test bench on which we perform efficiency tests with a bit of a special electric drive axle. So let's have a look inside. The drive unit, which is used in these investigations, comes from the latest Opel Ampera E model, which is pretty much the same as the Chevrolet Bolt. Both of these are only available as battery electric vehicles. Just like I said in the beginning, this axle is a bit different to other electric drive units. As the small gearbox with one gear and the electric motor aren't separated, there's only one fluid to lubricate all parts of the gearbox and to cool down the stator windings. The oil is pumped from the oil sump through various openings all over the stator windings and flows to the gearbox afterwards. Therefore, the oil has to provide good lubrication and cooling for both motor and gearbox. To prevent the motor from overheating, as the oil temperature rises significantly when driving with higher loads for a long time, there's an additional water cooling system integrated inside the axle. The effect on temperature depends on the additive package and quality of the oil in use and has a major impact on efficiency. By comparing the measured power at the end of all driven cycles, we can determine a test result and calculate the efficiency of each oil. The better the oil, the lower the energy consumption. Hi, I'm Ruven Kirchhoff and work for APL Landau as a project engineer. My focus is on testing all kinds of fluids in electric drive units. In this video, I would like to show you a test bench on which we investigate the wear of gearbox and differential parts of those electric axles. So, let's have a look inside. Here you can see our gearbox, which we are going to test, and this is integrated in our test setup. The setup consists of our driving motor and our two wheel brakes. The current test is built for a VW ID4 test. As we all know, the car drives fully electric, so the gearbox only has one gear, which is there to reduce the high RPM of our electric engine onto the streets to bring our power and torque onto the wheels. But only this one gear is able to let the car drive up to 160 kilometers per hour. As we are capable of controlling each motor by itself, we can set different wheel speeds to simulate driving in curves on a real road. This gives us great flexibility to run various test cycles in order to precisely investigate the different loads in real driving situations. By running identical test cycles with different oils, we can point out the impact of varying additives by comparing the measured torques or the damage of previously defined parts after a series of tests. With this special climate chamber, we can investigate the effect of very low and high temperatures on our gearbox and the oil in it to simulate driving the car in winter or summer. Regarding some well-known cycles like the WLTP cycle, this chamber helps us to provide precise starting temperatures in every part of the gearbox to get the best reproducibility.
Hello, my name is Axel Schick and I test fluids in electric drive units. Today I want to show you a test stand where we investigate the wear in such drive units. So let's go inside. Here we have the drive unit of the Volkswagen ID.3, consisting of an electric motor, a power control unit that is controlling the electric motor, and the gearbox that is reducing the high speed of the electric motor to the speed that is needed at the wheels of the vehicle. We have now disassembled the drive unit and you can see the gearbox we want to investigate in this test stand, and of main interest is for us the wear of the gear wheels and the differential. So now here you see the gearbox integrated in the test stand setup, consisting of a driving motor and 2 wheel brakes. And with this setup we are now able to offer a test to our customers from the oil industry to test their additive packages in regard to wear properties.